So in the beginning, I given you some brief introduction. What is orthographic projections, isometric projection? Okay. So let us see in detail what is orthographic projection at all. So I am reading for you one line. Orthographic projection is a technical drawing in which different views of an object are projected on different reference planes, observing perpendicular to respective reference planes. I given you already some basic input, right? Horizontal plane, vertical plane, profile plane. Okay. Now where you are sitting or standing, that is the ground, right? That ground plane we are calling it as horizontal plane. In front of you there is a vertical wall. You treat it as vertical plane. That means a large area. Okay, some rectangular area. We calling it as vertical plane. And perpendicular to these two, there is right hand side. You will see in you are sitting in a room, right? Room is having four walls, right? So the ground floor I am calling it as horizontal plane. The front wall in front of you, okay, you are observing, right? That is vertical plane. And the right hand side or left hand side there is one more wall, right? That we call it as profile plane. These three are reference planes, okay, on which we are going to draw the projections. See here, projections are nothing but front view, top view, and side view. So if you see any object, it is having front elevation, top plan, and side view. Okay. So to understand a particular object, you require these three views. Okay. So these three views are drawn on these three reference planes. These are the reference planes. Okay, we need to have some reference, right, to draw to relate one figure with other figure. We need to uh, relate. So that's why these standard reference planes are required. So orthographic projection is a technical drawing in which different views of an object. Okay, different views. Okay, now I will ask you simple questions. If you take a cell phone object, okay, suppose if you uh, keep the cell phone in front of you, okay, you will see the total display, right? That is the view. Suppose if you see from the top, you will see only small width and thickness. Okay, you don't find any display glass. Okay, and if you see the same object left hand side, again you will find some rectangular thickness of the cell phone, right? That means we are drawing. Technical drawing means a little bit precision drawing. With the help of instruments we are drawing, okay, with accuracy. So we are drawing three views, basically three views. There may be so many other views, but primarily we require three views to say that whether this is a cell phone or a pyramid or any cylinder, or what is the object. It is not possible in one view to tell. Okay, so at least we require three different views. Okay, so one view I will draw on HP, one view I will draw on VP, other view, okay, we will draw on the profile plane. So three different planes are required to project these views. Okay, so let us move further. You can understand. For example, see here, uh, a person is here, is watching. So this symbol, the person is standing here, is watching this object. This object is having one face A, something like it is cuboid, okay, or cube, you can say. If all faces are equal, you can say cube, otherwise it's cuboid. So a person is looking this object, right? A, B, C. Okay. Now you may not see the other faces, but there are uh, parallel faces are there in opposite side. Okay. Let us say only three faces. So this is my object A, B, C. This is the person. Okay, a person is looking this object, right, in this direction. So he is in front of A, right? He is in front of A. So maybe it is a front view of that person. Okay, so this face A is falling on one reference plane. Okay, front view generally falls on vertical plane because a person is standing here, is looking this object, is throwing the image of this face, this image A because he can't see in the front view direction BC. He can see only A face. So that face, A face, is in the shape of some rectangle. It is projected onto one reference plane. Okay, now you can see somewhere it is projected. Let us take in front of VP, in front of person, the plane is always vertical plane. So this A particular A face is falling on this particular vertical plane. Okay, so I call it as A. Is it clear,
Yes,
student?
sir.
Okay. Now remember, you are standing in front of one vertical wall. Okay, so in front of you there is a vertical wall, and between you and vertical plane there is an object like this. So the image, because your eyesight, right, eye rays are falling perpendicular to this vertical plane. So that's why it is called orthographic projection. Understood why it is called orthographic? Means the person is standing here at a lot of far distance, infinite distance away from the object. Assume like that, okay? Not close to this object. The person is standing at infinite distance, and his eye rays, okay, you are looking, okay, uh, horizontally, right? Your eye rays are falling horizontally on the object. Okay, that means perpendicular to the vertical plane. Do you understand the difference? The rays are horizontal, falling on the object, but the rays are perpendicular to the plane of projection. Plane of projection means our reference planes. Okay, because this projection or this view is we are projecting onto vertical plane. That's why we call it as plane of projection. So, one rectangular shape, that is the face of the object A, is falling on VP. Okay, imagine like that. So if you take imagine a person is standing or looking the object from above, from uh, top to bottom he is looking. So can you able to identify the person is here looking the direction I am showing you here? Now tell me which face you can able to see. A, B, C.
Horizontal planes.
No, no. Out of three, yeah,
C face.
C face, right? C face only you can see because he's looking the object from above. Okay. So, but where it is falling, that image, the iris. So this particular C face is falling on which plane? Which reference plane?
Horizontal planes.
Horizontal plane. Very good. So that is the, because we are looking from top. Yes or no? We are looking from the top. I call it as top view. So earlier we are looking from the front of the object, so that is called front view, which is falling on vertical plane. Now we are looking the object from the top, which is falling on the horizontal plane, or we are projecting that image of the object onto the horizontal plane. We call it as top view. Okay. So is it clear? Can we draw? This is, assume this is a horizontal plane. Okay. Now on that you need to draw one rectangular box, because the C face is in the shape of rectangle. Rectangle, you know, four corner points are there, right? So this is the top view. Now, can you imagine same in the same way? Can you imagine side view? Can you imagine side view? Now, here you see, person is standing somewhere here. Okay, looking the object from the left hand side. From the left hand side. So what happens? Okay, see, this is the direction, side view direction. Okay, am I clear? Side view, this is the side view direction. A person is standing here looking the object. Okay, the eye rays are always horizontal. uh, okay, imagine if you focus a torch light. Okay, that rays are falling on the object, right? The rays are horizontal, but the plane, okay, on which the projection falls will be perpendicular to the rays. That's why it is called orthographic projection. Now you can see the side view is falling on one more plane, that is profile plane, side view. Okay, So again, the side view is in the shape of a rectangle capped. You see the face. Again, it's a rectangular box, right? So you note down this is the side view. In this way, you need to represent orthographic views. We can call it them as orthographic projection. Now, so here we are discussing only three important views: front view, which is falling on VP, top view falling on HP, side view falling on profile plane. Okay. So to represent these three views, we require three important reference planes. So we have taken horizontal plane, vertical plane, profile plane as reference planes. Now, again, I am repeating that HP, assume it as the ground, because we need to relate all these concepts for real-time problems. Okay, you are standing on the ground. Okay, that ground floor we call it as horizontal plane. In front of you, there is one vertical wall. You call it as a vertical plane, and the object is kept in between your uh, you and the vertical plane. Okay, as long as uh, this projections is valid for if you are standing infinite distance from the object. Okay, on the rays, your eye rays, the eyesight rays are parallel to the ground floor but perpendicular to the plane of projection, vertical plane. Okay, that's why it is known to be orthographic projections. Okay, now, so here I would like to give one more introduction to isometric projection. Instead of drawing front view, side view, top view, three different views, why can't I draw one single view? Okay, so this object itself, it is you are looking this object, okay, in a single view. So it is having length, width, and height. So I am representing all three dimensions in a single view. This view is known as isometric view. If I require separately front view, top view, and side view, then I have to draw like this. That is called orthographic view. So orthographic view,
Orthogonal
yeah,
project.
yeah, orthographic view or projection means multi-view, multi-view, multiple views are there: front view, top view, okay, side view. But isometric view represents only one view. Okay, you can directly identify the given object is something like cuboid or cylinder, okay, or some other solid object. But if you look at this top view, which is drawn onto the horizontal plane, can you say this particular object is a cuboid by looking this only single top view? Is it possible?
No, sir.
Yeah, it is not possible. So you require at least two or three. Okay, then only I can say that by uh, experience, I can say that by looking at all the three views, I can say it's a cuboid. Okay, or if I by looking the object, I can see by the three views, I can say it's a cylinder or pyramid. Okay, so multi view representation known to be the orthographic views. Okay, so single view, we can other, there are so many other names like 3D views. Okay, isometric view,
Pictorial.
pictorial view. Okay, so I think you are remembered. Yeah, so those are so many names. Let us move further. Okay, so it is very important to represent on the drawing sheet, right? Suppose a point is there. Let's take that point. The point is having how many dimensions? Zero, right? If
Infinite
you,
dimension.
yeah, a point, if you take, so simply you put a dot on the drawing sheet, it is having no length, no width, no thickness. Okay, you can say simply point. So if you take a line segment means it is having a small length, okay, but no width, no thickness. So it is one dimensional element, line AB, one dimension. It is having only length. But point, No dimensions. You don't have any dimensions for a point. So simply on the drawing sheet, I will put a small dot, okay, small point. So for example, how to represent these things on the drawing sheet? These are the notations. You need to notate, just write on the drawing sheet. For a point, you can take small letter if it is a top view. If it is a front view, small letter with dash, a dash, okay, or I can say a prime, okay, a double dash, a double prime, okay. Small letters we have to use on the drawing sheet to represent the projections. Actually, given point will be capital letter, given line may be capital AB, but while after drawing orthographic projections, we are calling them as top view, front view, side views, right? So on your drawing sheet, never use capital letters, especially this particular topic, okay? Projections of points, lines, and planes and solids. These are the various topics we are going to discuss. We are starting with the point and line initially, okay? And these are interrelated mutually, okay? So you need to understand from points, okay? If you take two endpoints, join together in a straight path or shortest path, you would get a line, okay? We will discuss in detail later. So representation of these projections on the drawing sheet, you have to represent top view. If it is a point, capital A, then its top view will be small letter a, okay. If the given point capital A and its front view, you have to represent with small a dash. Now I would like to ask you one question. Suppose you are given a point capital A, its top view small a, okay, and its front view a dash, okay, is given. Okay, now tell me, by looking at small letter a, can you say whether it's a top view or front view? You are given small letter a. That means you need to understand indirectly, you need to understand its top view only.
Top view.
Okay, if it is given a dash, the front view of the given point capital A is given. That you need to understand. If it is a double dash is given in the problem, okay, small letter a double dash, okay, that is the side view. Similarly, you can apply the same concept for line because line is having two endpoints, okay. So its top view will be small ab, its front view will be a dash b dash, and side view a double dash b double dash. For example, you see a rectangular plane, four corners are there. If I given you small letter a b c d, what does it mean? It's a top view or front view?
Stop using.
Very good, because there is no dashes, no primes. Okay, it's simply small letter a b c d. So according to the notation, so notations are very important in engineering drawing. Okay, you have to look carefully observe. Okay, even though when you answer the problems, if you write a dash b dash c dash d dash, okay, instead of a b c d, the okay, you will get negative marks. Okay, so this is the top view without any dashes. Okay, primes. If it is a front view, you have to go with the a dash b dash c dash and d dash. Now here you see I am mentioning a prime, b prime, c prime, d prime. What does it mean? It is
Front view.
the
Front
front
view.
view, the front view of a given object. So this is the representation actually. Okay. So here I am drawing some planes, square plane, okay, or rectangular plane. So here four corners are coming, okay. Even though it is applicable for line, line is having only a dash b dash, okay, only single length. There is no other dimension for line, okay. In this way, you need to represent different views. The notations are important, remember, okay. Now there will be some format to remember all those things. We will see. Now, do you know there are four different quadrants?
Yes, sir.
Which are there? First quadrant, second quadrant, third quadrant, fourth quadrant, right? Okay. Let us see in detail. Okay. So here, before going to that one, I would like to give some overall picture of projections because the entire second, third, fourth. Okay, second, third, fourth, all, and including fifth unit also. We are having so many topics. Okay, all depends on the topic we are discussing now. Okay, projections. All are interrelated. So unit number 2, 3, 4, 5. All are depending on the concept. So that's why I'm going for a detailed overall picture. So if you see projections, now we are discussing, right, orthographic projection, isometric projections, what I'm saying, right? So let us see the overall picture. Okay. So projections are subdivided into two parts. So parallel and converge projection. So again, parallel projections, again divided into orthogonal, oblique, orthogonal, oblique. Now orthogonal, just now we have discussed multi-view and axonometric. Okay, so multi-view, again we are having in the multi-view, simply we have top view, front view, side views. Okay, just now we are discussing, right? We need to draw top view, front view, and side view because three views are there. So more views. Okay, more number of views. That's why it is called multi-view. So axonometric means it's a single view. One example is isometric view. Just now I have discussed, right? You can see all the three dimensions in a single view. But in case of multi-view, in the top view you can see only two dimensions, front view only two dimensions. Okay, it's any plane object is there. In the side you can see only 2D, all 2D uh, views. But coming to axonometric 3D view, okay, you can directly identify which is the given object. Okay, here unless we are given 2 3 views, you cannot identify or recognize a particular object. Similarly, so in orthogonal we are having a multi-view and axonometric. Okay, so in orthogonal projection, okay, what I said, the rays, eye rays are parallel to each other and perpendicular to the plane of projection. Okay, so that's why the meaning is parallel. Okay. Now, in the oblique case, the rays are not parallel to each other. That is the only small difference. However, this oblique projection and this converge projection, not in our syllabus, but remember in the orthogonal projection, the rays are parallel to each other and perpendicular to the plane of projection. So what we have discussed right here. But coming to oblique, the rays are not parallel to each other. Okay, and so this perspective drawing converge. Here also the same thing. Okay, we will see the building elevation. Okay, if you take a photograph, you would get a different image that comes under this perspective drawing. So this is not there in our syllabus. We are more interested in orthogonal projection, multi-view and axonometric. Multi-view and axonometric. ISO. We call it as ISO. These two we are having in our syllabus. Now coming to as we discussed, right, multi-view drawing. So front view, top view, side view, we have to draw like this. Okay. So pictorial drawing or isometric drawing, we need to draw like this. In a single view, we need to draw perspective. It is camera view. So we will take some photographs from, if you are close to the building, right, you will get one type of picture. If you are far from that building, you will get a different image, right? So again, it's a single view. that we call as converged projection or perspective drawing. Okay, again, the same topic, it is repeated in the unit number 5. At the time, we will discuss in detail. Okay. Some theory is given, right? Actual accurately represent what is multi-view accurately presents objects, details, size, shape. Okay. So here it is required training to visualization. So in our subject, we will get trained. So how to visualize a particular object, what is its side view, how to view it, okay, what is the top view, how to draw its different views. Okay, so pictorial drawing, it is easy to visualize. Okay, here one more comment on this is shape and angle distortion. Okay, here perspective drawing, object looks more like what our eyes perceive. Okay, here you can see. So you see that suppose you take a highway, okay, so a longer highway, so the dead end you can see very close to each other, but wherever you are taking photograph, right, at that time it is wide enough. Okay, so such things you may observe even while you are traveling in a bus. Okay, the roads are closed if you are uh, at far distance to you, but road is very near to you. Okay, that is called perspective drawing, perspective projection. So it is difficult to create size and shape distortion. Okay, that much not accurately you can see the particular image. So anyway, perspective drawing is not there in our syllabus, and pictorial drawing and multi-view drawing we are focusing on our subject. Okay. Now we come to some important thing. Here we have already discussed. However, we are representing on the drawing sheet, or we are representing on a paper like this. Vertical plane, I said it's a large area, right? It is something like vertical wall. So it is shown on the drawing sheet like this, VP. Okay, and horizontal plane is again the ground on which you are standing. Okay, so this is the horizontal plane. Now uh, there are so many other planes you need to learn. Okay, for the future topics. Just I would like to brief here. So here there are some other planes to represent a particular view. Okay, sometimes not only front view, top view, and side view, some other views are also required in our drawing. Okay, so at that time we are having some auxiliary planes. Here I am showing you auxiliary planes. First auxiliary plane is auxiliary vertical plane, AVP. Remember AVP. Now, can you tell me this yellow colored auxiliary vertical plane is perpendicular to HP and inclined to VP? Am I right?
Time, sir.
Yes, sir.
Yeah. So perpendicular to HP, it is kept like that, right? On the ground. Okay. It is kept on the ground. That means perpendicular to the ground and away from VP. Away from VP at some angle. Okay. That is, we call it as inclined to VP. So this is called auxiliary vertical plane, inclined to vertical plane. Okay, perpendicular to horizontal plane. Now this is one additional reference plane. Okay, we call it as auxiliary planes. So our primary planes are always vertical plane, horizontal plane, and profile plane. So these are auxiliary planes. Now I think can you auxiliary vertical plane? It is perpendicular to HP, inclined to VP. Okay, that means it is rotated at an angle theta from vertical plane, and keeping this total area of the vertical plane is perpendicular to the ground. In that way, you need to understand. So here one more plane, auxiliary inclined plane, AIP. Okay, how to describe this AIP now? How to describe? How to describe? It is inclined to
Horizontal.
yes,
Horizontal.
inclined to horizontal plane. That means actually it is rotated at an angle theta with HP. That's why it is inclined to HP. And however, we are maintaining the total area of a auxiliary inclined plane perpendicular to the VP. Okay, perpendicular to the VP. So lastly, we will see that profile plane. Profile plane already we have discussed, right? Which is perpendicular to both HP and VP. So here again, this rectangular yellow plane I am showing you here. Okay, so it is resting on the ground. Okay, resting on the ground. The surface area of the plane, that the yellow plane, is perpendicular to the ground, also perpendicular to the VP. Yes or no? It is perpendicular to both HP and VP. So this is known to be the profile plane. In this way, we can have three more additional. If you take HP and VP are primary, okay. So AVP, AIP, and PP are additional planes. Okay. So these two are called auxiliary planes, and this is also comes under auxiliary plane, but we are having a specific name for that, profile plane. Okay. So anyway, these are reference planes. We will draw front view on VP, top view on HP, side view on PP. Okay. Some other special views. Okay, that is true shape. Okay, such I will discuss later. Okay, some other views on AIP and AVP. Okay, so tell me what is the importance given for auxiliary planes. We will draw some additional views on the AIP, AVP, like we are drawing front view and top view on HP and PP. Okay, that means some other views we require to draw. Okay, on the drawing sheet. Okay, we require AIP, AVP. We will see that comes under some other unit. So here, so if you combine all these three, let us take VP, HP, and profile plane. Okay, now you will get one quadrant. Okay, so like that, if you take a you can frame three different four different quadrants. Okay, so here because you are drawing front view and VP, here one important concept, listen carefully. We are drawing one view on VP and other view on HP and side view on PP, right? Now, actually, these three reference planes are perpendicular to each other. Yes or no? Uh, Let us assume this vertical plane is one drawing sheet, horizontal plane is another drawing sheet, profile plane is another drawing sheet. You are having so many drawing sheets, right? I'm telling, okay, a piece of paper. Okay. Now, understand here one important concept. Your drawing sheet, after fixing on the drawing board, it's a plain paper, right? It's a plain sheet. Okay. It is not folded like this. It is not, you cannot see drawing sheet like this, right? VP vertical, HP horizontal means you are not having the drawing sheet perpendicularly folded like this. Okay, that means what I mean to say is it is not possible for you to draw, okay, on three perpendicular planes, to draw three different views, front view, top view, and side view. You are having a plain sheet of drawing sheet, okay, on which you need to represent all the three views. Okay, you can't fold your drawing sheet in this format and you will draw here some front view, here some top view. It is not possible, right? So what you have to do? You need to make it unfold. Unfold it. Unfolding means what you have to do is just you see the procedure, what we are drawing, okay? How we are getting the different structure. What you have to do is HP we need to rotate 90 degrees downwards. Just you rotate HP clockwise 90 degrees and profile plane 90 degrees right side, okay? I will show you. Maybe we can understand, you can understand, otherwise I will show you one more pattern how to think it, think of rotation, okay? See here. So what I am doing is vertical plane I kept as it is, okay? The HP I am rotating clockwise 90 degrees downward, okay? So what I have done is I am making this HP in line with VP, in line with VP. Now only thing is profile plane is as it is till now. So again what we have to do, rotate this also like this, so that all three sheets are, or three planes are, I can say all three planes are in line with each other. It appears something like your drawing sheet, okay? Now look at, this is very important and fundamental concept in our projections, okay? Now you see finally what I have done, actually these three planes are perpendicular to each other, okay? So front view is coming on to VP, top view is coming on to HP, and the side view is coming to PP. So our drawing sheet is not like that. So what I have to make is, I have to make all these three perpendicular planes in line with each other, in line with each other, like horizontal drawing sheet, okay? So what I have done, HP I have rotated clockwise 90 degrees, and profile plane, okay, I have rotated 90 degrees right hand side, or you can imagine like this. Now finally we got one picture, okay? So this is front view, because HP clockwise rotated 90 degrees, right? Top view is coming down below the front view, okay? We have rotated that profile plane also right hand side, so it is coming to the front, right hand side of the front view, okay? Right hand side of the front view. Now when you draw on your drawing sheet, you need to remember, you need to draw the front view first, okay, or top view. So so top view and front view should be in one line, and front view and side views must be on some other line. Now so this is now your drawing sheet. So whenever you draw three different views, multiple views, so there must be a line xy. Xy is nothing but, here you can see from this figure I can show you, which is common line for HP and VP, XY, okay? So that is the separating line from VP and HP, okay? So this is the reference line, I call it as a reference line. So above vertical plane is there, that I have not done anything with that, okay? Okay, now it is the front view. Since I have rotated HP clockwise 90 degrees, it has come down. So below the front view, I have drawn top view. Next, side view. Side view is coming here. So I got left hand side view. I am getting right hand side of the front view. Now understand, this method is valid if the object is in the first quadrant only. Next, in the next class, we will see what happens if the object is in the second quadrant, third quadrant, or fourth quadrant. Then we will see, okay? Assume that in the first quadrant, again we will discuss quadrant system, how to think it of, okay, the views, how to rotate clockwise at 90 degrees, everything we will discuss in the next class. I think because we are already late, okay, Do you have any questions?